I think the definition for me is very straightforward. It's about getting more output with less effort in shorter time. It doesn't have to be more complicated than that. But the other dimensions to process intensification are really decisions of what to do and when to do it. And the when is about matching the need in the actual phase of the development with the technologies. And the what is really about deep diving into each unit operation and removing bottlenecks, eliminating steps, uncoupling and front loading, but also combining and integrating different unit ops and processes.
Ever wondered how process intensification could revolutionize your cell culture operations? Today, we're exploring game-changing innovations that will transform bioprocessing in the next decade. Welcome to the Smart Biotech Scientists. I'm your host, David Brühlmann, and I'm joined by Andreas Castan, a 25-year industry veteran who provides leadership and support to Cytiva's bioprocess business. Andreas will break down what process intensification really means for practical bioprocess development and shares the technologies that represent true low-hanging fruit. Let's dive in. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brühlmann, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. Welcome, Andreas, to the Smart Biotech Scientist. It's good to have you on today.
Thank you, David. It's a great pleasure to be on.
Absolutely. It's a pleasure to reconnect. And Andreas, share something that you believe about bioprocess development that most people disagree with.
Yes, sure. I thought about it, and for me, it's actually AI that is overhyped in bioprocessing. And the reason is actually that for me, it's still the kind of human expertise that is important, because at the end of the day, process engineers and biologists make the call and take the decisions, where our AI is only assisting. I'm lacking the mechanistic insights. I'm convinced that the data in bioprocess data are often noisy, and very often what people are doing is basically fitting the noise and overfitting. So therefore, blindly trust on AI, I don't think is the way forward, but rather connect it with mechanistic insights and work with hybrid models. And again, a kind of shout out to all young scientists, continue what you are doing and get trained in biotechnology and cell biology, because the human expertise is still key.
Yeah, you're making a great point. And we would also love to hear from you, Smart Biotech Scientists, what you think. Is AI overhyped, or is it in between? Or what do you think about AI? I would also love to hear from you. Before we dive deeper into the bioprocessing side of things, Andreas, I would love to have us draw into your story, because you have a fascinating journey from starting bioengineering at KTH now to working at Cytiva. Draw us into your 25 plus-ish years of work, and also tell us what sparked your initial interest into bioprocessing and what were some interesting pit stops along the way.
I'm happy to do that. For me, it actually started as an undergraduate student. I was fascinated by applying concepts of chemical engineering on biology, and very soon it became also creating something that has a benefit in the end for patients. And when I moved into the industry, my first project were in cancer therapy. They didn't make it to the market, but getting the feedback from the clinics back onto my work was really very rewarding to have that connection. And after that, I got the opportunity opportunity to start an industrial PhD where I had the chance to deep dive into scientific matters of my work, developing soft sensors, developing scaling strategies. That was also a good thing. And after that, I'm heading up GMP and non-GMP pilot plants and learning about the rigor and the robustness that is required in manufacturing. And after that, I followed my former manager into what is now Cytiva, starting up the bioprocess business and contributing with my insights as a customer again to deliver solutions that in the end come to a benefit for the patient. So that is kind of a common theme which makes me get up every day.
Yeah, that's fantastic, Andreas. And I imagine you have seen a lot of transformation in our industry in your various roles in various companies, small and big ones. Can you tell us a bit what has evolved and what were some fundamental shifts in our industry?
Definitely in the 25 years I've been working there have been a lot of shifts. Basically improvements in the whole development cycle, developing process platforms for maps, streamlining workflows, but also improving the relationship collaboration inside the company between upstream and downstream with external partners like CROs. The technology is evolving with respect to expression systems, cell culture media, affinity resins, cell retention devices. And not to forget single-use technology, something I'm working on daily with today, has really accelerated PD and manufacturing. And when I think back to the first IND I was involved in filing, it took more than 2 years to do that. And today I'm hearing that timelines are down to 6 months. So the efficient work process that have evolved over the last 25 years and the map or the process platforms for maps that people are now looking for new modalities, I think have really been one of the most important developments.
What do you think, Andreas, were the main drivers or the key enablers to now enabling companies to do an IND filing in 6 months instead of a couple of years? Is this a technology thing? Is this more insights? Is this the way how we collaborate? Or what do you think?
In these very aggressive timelines, I think it's a progress in cell line development so that you very early get pools that are representative for your final clone so that you can produce tox material with these pools. That is one thing. Second thing is that you utilize a platform. If you start from de novo, you will not make it, but leveraging the platforms and doing minimal development work. And thirdly, I think it's just the ability to take risks and to handle risks. For example, produce first in human material with a master cell bank that is only preliminary release and then waiting for that release for filing the IND. These type of story or strategies are the enablers I'm seeing.
And what do you think will be the enablers in the future? Because we have a lot of new technologies or new ways to work. What are some game-changing innovations you see on the horizon?
I would like to highlight 3 things in the shorter term. The integration of PAT, hybrid modeling. I mentioned that already in relation to AI, connecting machine learning with mechanistic insights. And then I think more automation is the third pillar I'm seeing. And all 3 will help to develop digital twins that will act on the process variability, avoid deviations before appear, and drastically reduce the variability. And I think it will also allow to create autonomous bioprocess labs with robotics that will kind of further increase the throughput, streamline the timelines. And I think we are seeing this already demonstrated in the industry. Just, I think 2 weeks ago, there was a nice publication from WuXi demonstrating it. I think Merck Serono has built their labs around these strategies, basically tying these 3 components together.
So just to reiterate for those who might not be so familiar with these digital technologies, you mentioned PAT modeling, just to understand, like, what is the main enabler of these technologies? Does it help us gain process understanding faster? Is it also allows us to connect the dots much faster and make better decisions? Or what are the advantages you see with these new technologies?
Exactly. The kind of real-time decision support for me is very important to basically predict deviations before they occur and enable interventions. but it's also to accelerate the development, asking what-if questions without running physical experiments, to scale up in tech transfer and simply modeling different conditions, and overall increase the process understanding, combining data-driven and mechanistic insights to basically discover hidden dynamics in the process.
Definitely, you're making a good point here. Process understanding is key. This is also something I tell a lot of people I'm advising, having conversations, especially people coming from startups or still at the university. They sometimes underestimate that part, but gaining process understanding very early on in process development is key.
The regulators are very specific with that, also saying that process understanding and patient risk are in different parts of the balance. The more understanding you have of your process, the lower is the risk for the patient and vice versa. So I think therefore the regulator will chase and seek and force you to demonstrate.
Before we continue, biotech founders, I want to talk directly to you. Do you know that feeling when an investor asks about your manufacturing strategy and you freeze? One wrong CMC decision can cost you $2 million and 18 plus months of delays. Yet many CEOs are flying blind on these critical decisions. That's why I created the 1-week CMC strategy assessment. In 1 week, you get a personalized assessment of your molecule and development stage. We identify critical gaps before they become million-dollar mistakes, plus a strategic roadmap for high-stakes investor meetings. One CEO told me, "David took me from feeling powerless about our CMC roadmap to confidently pitching investors. An absolute game changer for time-pressed CEOs." Whether you are preparing for Series A, approaching IND filing, or facing scale-up challenges, this gives you confidence to ace investor and board conversations instead of surviving them. Ready to stop second-guessing your CMC strategy? Check the link in the show notes and secure your spot. Because your breakthrough therapy deserves a solid CMC strategy. Now, let's get back to our episode.
Understanding.
I'd like to dive into a bit more now in a few innovations. One of them is process intensification. It has been around for a while. You hear all kinds of different terms. It's thrown around. But what I've noticed, it's not always well understood actually what it means. For certain people, it means this. For other people, it means something else. So let's start peeling the onion, let's say from the beginning. Can you tell us, Andreas, what process intensification actually means in practical terms and for someone who is working in mammalian cell culture processes?
I think the definition for me is very straightforward. It's about getting more output with less effort in shorter time. It doesn't have to be more complicated than that. But the next or the other dimensions to process intensification are really decisions of what to do and when to do it. And the when is about matching the need in the actual phase of the development with the technologies. And the what is really about deep diving into each unit operation and removing bottlenecks, eliminating steps, uncoupling and front loading, but also combining and integrating different unit ops and processes.
Let's talk about one of the innovations that changed bioprocessing at process intensification, and it has been used in various aspects, in various circumstances, and can mean different things to different people. So tell us, what is your definition of process intensification, and perhaps give us a few examples.
For me, the definition of process intensification is very straightforward. You want to get more output with less effort in a shorter time from your plant. The question is more about what to do and when. And the when is about finding the need for an actual phase in the development. And maybe we can look into that in details. And the what is about deep diving into each unit operations and make a decision. What are the bottlenecks? What steps do we want to eliminate? Do we want to uncouple different steps or front load these or combining steps into fewer unit ops in the process?
Can you give us one or two examples of process intensification? How does that look like, for instance, on the upstream side and one on the downstream side?
Actually, I could give you a long answer, basically looking into the time axis of development, starting with the very early research where speed is key. I think it's worth putting efforts into miniaturization and aligning the throughput in process development, in analytics. In the DOE phase, in the PD phase, I would work with setting up good DOEs, performing those and leveraging platform knowledge that then can be fed into the in silico, the hybrid models I mentioned, to leverage the output from them. So these are the things I would to highlight in the early phases. When it comes to clinical manufacturing, where productivity is important, I would recommend to start focusing on the seed train. That could be using high inoculums from vials or bags, introducing perfusions, early steps in the seed train, leveraging the bioreactor turndown ratio to eliminate steps in bioreactor steps, but definitely N-1 perfusion. And I think everybody is talking about that. N-1 perfusion allows you to inoculate the production bioreactor at higher cell densities, for example, 10 million cells compared to the 0.5 million. And the worst case in that scenario is actually that you reach your peak cell density, your peak titer shorter and increase the output. But in many, many cases, you will also see that you have happier cells that grow better, that produce better, and that you can not only harvest your bioreactor earlier, but also at a higher titer. And in our labs, we have seen the titer increase of about 30 to 50%, but there are reports in the industry of titer improvements of up to 150% using this N-1 perfusion high C fed batch strategy. And to briefly mention the downstream, of course, you can intensify in clinical manufacturing there as well, using high capacity capture resins or multi-column chromatography and membrane absorbers in operated and flow-through mode and polishing.
When I was working in big biotech, we often had the luxury to spend quite a considerable amount of time developing these process intensification steps and technologies. Now, as someone who leads a smaller company, often what I hear is, well, where do I start? What can I do? Where are the low-hanging fruits? What would be your recommendation to someone who doesn't have so many resources? What should they do?
Actually, I almost should have started with that. One of the very powerful process intensification strategy is to develop a cell line that is high producing. It's a significant difference to start with a cell line that is giving 3 grams per liter compared to one that is giving 6 grams per liter. So here it's definitely well spent resources to develop these cell lines or go to a specialized CRO that can help with the development. That would be very, very well spent money. For larger organizations, like you said, everything is in-house. They know their technology, they know their manufacturing network, they know their toolbox, and maybe what I outlined for the clinical manufacturing are actually the low-hanging fruit that you should focus on. Smaller companies often lack the experience with all these technologies, and for them it's even more important to understand the bottlenecks in the process and in the manufacturing setup and focus on these, and also work together with technology providers to understand the technology and let them help to charter the course for implementation. I, for example, work a lot with this type of customers to identify the solutions that make sense for a specific project and customer. And finally, what I have found very useful is using process economic modeling to understand the impact of different scenarios. Like I mentioned, the cell line productivity or scaling up or scaling out of intensified fed batch versus continuous scenarios. That can also give a lot of insights.
And when should they do that? Does it make sense to start with that in phase 1 as you're preparing your IND, or would you recommend doing that later?
Actually, these kind of low-hanging fruits I would consider already in the first-in-human process development. When you then have removed the uncertainties and you think about commercial process development, I think then you could add another layer. And again, for example, look into continuous viral inactivation or cyclic virus inactivation, look into inline conditioning for buffer preparation, revisit cell culture media and feeds. That would be, for me, the kind of second step in developing really a well-developed commercial process.
That wraps up part 1 of our conversation with Andreas Castan. We've explored the evolution of bioprocessing and unpacked the process intensification toolbox. In part 2, we'll dive into continuous manufacturing strategies and the economic realities of implementation. Do you have burning questions about process development challenges? Book a free consultation with me at Brühlmann-Consulting/call, and please leave a review on Apple Podcasts or whatever platform you found us on. It helps fellow scientists discover the show. Thank you so much for tuning in today, and I'll see you next time. All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.